The average height for men in the United States, if I remember correctly, is 69 inches. Standard deviation, I think, is 2.8. I don't know. I have to look it back up, but let's go with that. It was true at least sometime within the last 4 years. If diets change drastically, it'll change again. All right, let me stop there. Is that cool? Everybody understand what that means? So that's okay. And we know that heights of men are normally distributed. Heights of Men. That sounds like a really boring movie. Heights of Men. I am 5 foot. So, let me ask you 2 questions. One of them is going to be easy, one of them is not going to be as easy. Work on this. Don't say anything out loud. 1, what percentage of American men are between, what, Jeff? Can you do it in your head? I don't know, man. 63.4 inches and 75.6 inches. 74.6, man. Almost got it. All right, here's one question. I think the blue's almost dead. Secondly, what percentage of men taller than, what, Jeff? I don't know, Jeff. 77.4 inches. Did I help? I don't know. Sounds like that should be the right numbers. Just to point out, that we did something earlier, somewhere up on the board. That's a really good, starting point. Somewhere up here. All right, so how do you attack that problem? What do you do? Draw it out? Draw a little dude? Sorry, draw what now? Okay. And what do you put in the middle? The mean? So what's one step up? And what's another step up? I got it right. Yeah, Jeff. Yeah, Jeff. And what's another step up?
77.
Jeff. All right. And what's one step down?
66.2.
Another step down.
63.4.
Yay! And then just for completeness, another step down.
60.6.
Who do what?
60.6.
60.6. Okay. All right. You stop there. So everybody with me. Some of you guys are squinting, and it's probably just because you can't read my damn handwriting. Exactly. I got the numbers in my head, just not in my hand. Yes? Yeah, that's how I got that. Yeah. So you take one step up, one step down. Add a standard deviation, subtract your standard deviation. So really, right here, what am I doing? What's the formula look like for this number? It would be mu plus 1 sigma. Oh shit. The mean plus 1 standard. This would be the mean minus 1 standard, mean plus 2 standard deviations, mean minus 2 standard deviations, so forth. And now, do you see why I was asking you that crazy-ass question? All right, figure out the mean standard deviation. What percentage of the data is within 1 standard? Because I wanted to relate that concrete example where you had freaking data to look at to these conceptual, theoretical ideas. Am I actually measuring any dudes here? No, this is theoretical. Based on observations, but still. So, how do you answer the first question? What percentage of men are between 63.4 and 74.6 inches?
95%.
Yeah, it's 2 steps, so it'd be 95% of men are between those 2 heights. All the men in here, do you know how tall you are? Anybody taller? What would this be? This is, what's this in feet and inches? Yeah, it was 6'2" and a half. Yeah, 6'2" and a half, almost a little bit more than 6'2" and a half. 6 would be 72 inches. Anybody tall? Any dudes taller than 6'2" and a half? Anybody? One dude. I like it. I like it. 2. Are you? Yes. You seem uncertain. You're taller, right? And you? You're 6'3". Okay. All right. So we got 2 people up here. Anybody shorter than 63.4? Sorry, don't mean. It's just biology. What the hell you want? Anyway, well, all right. Well, I'll leave you guys alone. If there's 95% in here, what percentage would be out there? 5%. So what percentage would be just on that side? Why are you allowed to cut it in half like that? A word somebody said earlier is normal, which means it is symmetric. Boogie woogie. So you can cut things in half around the mean. I always think that when I say that. All right.
It's symmetric.
So theoretically, there should be 2.5% of the men up there. How many men do we got in here? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. What's 2.5% of 25? It's like 1.5%, yeah. Which is close to 2, right? Well, there was no guarantee that that was going to happen at all. But the larger my sample, the more I expected to follow this pattern. If I had 80 men, I would put money on it being in a range around 2.5% of 80. Do you guys understand the power of this? The power. Okay, maybe. That's crazy, actually. So what about the number 2, then, you know how to do now? How do you answer number 2, then? That was just me riffing off of number 1. What about number 2? Yeah, what percent is in here? What percent is from here all the way up to there? 99.7% is within those. What percentage would be outside of those, then? So what percent would be on that side only? 0.15%. I like it. So above this, there's 2.5%. Above this, there's 0.15%. I like that. And we have nobody here over 6'5" and nearly a half, right? See, that would be less likely. If I had a larger group of people, especially a random group of American people, American men more specifically, I would expect 0.15% of them. So if I had 300 men somewhere just randomly show up, how many of them would I expect to be taller than 6'5", 0.4 inches?
Is that 1.5 or?
0.15, totally. Because this is 99.7. That's 0.3. So that must be half of 0.30, 0.15. I know our brain is like, well, that's not many. Part of our brain goes, that's part of a person. No, for 300 people, what would it be? I'm sorry?
45.
Yeah, 0.15, 0.0015. Right? You gotta be careful. 0.15% is 0.0015.
Yep. So 0.45.
So not even a full person. Which doesn't sound right. But all that means is that 300 people is not enough to guarantee that there's somebody that tall. I would put money on nobody being that tall, even if I had 1,000 people. That would just be 1.5 people. Tenths, hundredths, thousands, 10,000. I need 10,000 people just to have 15 men. Are you guys kind of with me? What is this number as a fraction? Tenths, hundredths, thousands, 10,000. So I expect 15 out of 10,000 on average men that are taller than 6'5.4 inches. So if I had 10,000 men, 15 of them, I would bet on there being about 15 of them that are taller than that. You with me? Now maybe there's 7, and maybe some other times there's 28. On average, out of 10,000, there would be 15. Let me let that all sink in. This kind of goes along with the probability section we're going to get into today. Oh shit. Okay, I like it. Okay. Alright, that's enough of that. That's enough of that. So that kind of problem is just playing around with cutting the percentages. What percentage would be between 0 and 1?
34.
34, you cut 16.5. I mean, so you can play around with those numbers in a lot of different ways. Once we get to chapter 6 and 7, we're going to beef this bad boy up. What if I was 1.28 standard deviations away? Does this say anything for me? No, it doesn't say shit for me. It only says something for 0, 1, 2, 3. So it's really, really good, but it's nowhere near powerful enough. So we're going to amp the power up in chapter 6 or 7, one of those chapters up there. Way in our future. Okay. Alright, so what I want to do actually is probably what some of you guys want me to do, is that, and that's to shut up for a while. I want to see how much you guys know already about probability. I'm going to give you a problem. You guys can work together on this. I'm not collecting this, so don't gripe about, well, he hasn't told us how to do that. I don't care. If you know it or don't. Do it if you do, don't do it if you don't. And then we'll do it together. No big deal. Let me write in English. There you go, Jeff. Good job. So you can imagine your own question, whatever question you want to imagine. Okay, so everybody make that little chart for me. This is something called a contingency table. I'm going to use the data that most of you guys provided me with and create contingency tables for you to attack on quizzes and tests and so on. There are other ways to do probability, obviously, but I want to start with this one because it's the one you always see. So let's say I ask a big group of men and women a question. Whatever question you want to have in your mind, I'm just not feeling creative. And let's say that 17 men said yes, and 42 women said yes. 51 men said no, and 11 women said no. 6 men said maybe, and 5 women said maybe. You guys with me? So let me do this. I've given you these as a hint maybe. So first question is, what's the probability if I pick one person at random? What's the probability that that person is a man? That's what this means. This means what's the probability that the person is a man? You guys with me? You know math people, we don't like writing a lot. And me specifically, I can't write well. So it's nice when I have a quicker way to say something. The probability that I pick a man, that's one question. What's the probability I pick somebody who said no? And then the third question I'll ask you is, what's the probability I picked a woman who said maybe? Alright, so you guys do what you can. If you can't do any of that, just draw a duck or something. Or work with somebody near you, maybe would be better. But at least make me feel like you're working on it. It would make me feel better. If you don't like ducks, you can draw something else.